This is a fresh installation of 3ds Max on Windows 10. I'll start with customizing the interface. So this is how to set up keyboard shortcuts. Go to Customize, Customize User Interface. That opens this window. In the Keyboard tab, you can see on the left side a list of all the actions and the shortcuts assigned to them. I'll find Select Object. I want to assign the key Q for that action. Type Q in the hotkey text box. You'll see the action to which the shortcut is assigned if there's any. Hit the Assign button and now Q is assigned for Select Object. Here's a list of the shortcuts I'll be using through this tutorial. Half of it is set by default. You can pause the video now and assign them if you want to follow along. Then you can save the settings file for later use, but that's optional. Next, I'll configure modifier buttons. You can have some shortcut buttons for your most frequently used modifiers, so that you don't have to find them from the modifier list every time. First, I'll hit this button and click Show Buttons to make the buttons visible. You can see that there are already some buttons with modifiers from the list assigned to them. Click Configure Modifier Sets icon again and click the top option to open the configuration window. Drag the modifier buttons and drop them over the list to unassign them. Find your favorite modifiers from the list and drag them over the buttons. Here are the ones which I use frequently. You can change the number of buttons. Hit OK once you're done. Next, I'll change auto backup settings. They're under Customize, Preferences, Files. You may face a situation in which the file you've been working on is corrupt. Auto backup gives you a file history you can use. I find 30 files and 10 minutes save interval sufficient. Max will create a file every 10 minutes and start overwriting so that you have 30 backup files and 300 minutes of history. Saves can cause an annoying pause depending on the size of your file. In that case, you can increase the interval. Auto backup folder is under Documents, 3ds Max by default. Next, I'll turn off the viewcube. It's not really useful and it's in the way. Right click this little icon and hit Configure. Clear the tick and show the View Cube option and hit OK. That's all for configuration for now. Next, I'll go over basic modeling techniques and fundamental operations you'll be doing frequently while modeling in Max. To create an object, go to Create tab and choose an object type, let's say a box. Click and drag in the viewport to decide the shape of the bottom face. Let left mouse button go. Move the mouse cursor up or down to decide on the height. Then click left mouse button to finalize. To end the creation process, either right click in the viewport or click the box button again. To move the object, hit W key or this icon, which is the default shortcut for select and move action. That will reveal a gizmo with 3 arrows representing the coordinate system. The small square at the intersection point of the axes is the pivot point of the object. Hold and drag the arrows to move your object. You can also type coordinates to move the object into these input fields at the bottom. Click at the empty space in the viewport to clear selection. Hit Q or this icon here to activate the Select Object mode. Click on the object to select it. Or you can drag to create a selection marquee. Hit R or click this icon to activate Scale mode. You'll see a different type of gizmo. You can scale the selected object along 1, 2, or 3 axes by holding and dragging at the different parts of the gizmo. Hit E key or click this icon to activate Select and Rotate mode. Now you have a spherical gizmo. Dragging at different parts of the gizmo will let you rotate the object around different axes. You can rotate by typing numbers at the bottom. You can rotate perpendicular to the current view by dragging within the large white circle. You can rotate freeform by dragging inside the sphere. Hitting spacebar maximizes the active viewport for me. If you haven't set up the shortcuts, the button for that is right here at the bottom right corner of the interface. I've been using camera controls, but I haven't mentioned them yet. Hold the middle mouse button to pan. Hold Alt key plus middle mouse button to orbit. If there's something selected, the orbiting will be based on the selection. Use the mouse wheel to zoom in and out. Hit Z key to zoom to the extents of the selection. In order to tweak the zoom increments, right-click on empty space on the main toolbar, select Customize to open Customize User Interface menu. Go to Mouse tab. Zoom increment variable can be set here. 0.2 is good for me most of the time. Close the window. You'll see the zoom action is smoother now. Right-clicking mid-action cancels the action. You can clone an object by holding Shift key while moving, rotating, or scaling an object. You can use the right-click menu or the designated shortcuts to hide and unhide objects. I assigned Hide Unselected to Code key, which is the key under Escape key in my keyboard. I assigned Alt plus Codes to unhide all. Delete key deletes the selected object. I assigned Shift P to center pivot action. It moves the pivot point to the center of the object. You can move, reset, center the pivot point by using the buttons in the Hierarchy tab. Hit Ctrl A to select all the objects or sub-objects. Hit Ctrl I to invert the selection. Standard objects in Max have some parameters accessible in the Modifier tab. F4 toggles edged faces. F3 toggles wireframe modes. In order to modify the object's faces, edges, and points, we need to convert it into one of the editable object formats and access the sub-object controls. I'll convert this box to an editable poly. Find Convert to Editable Poly in the right-click menu. Once you do that, the sub-object modes become available. You can use these buttons or the keys from 1 to 5 to switch between sub-object modes, which are vertex, edge, border, polygon, and element. Hit 6 to get out of sub-object mode. In any of the sub-object modes, you can work on individual or a group of that type of sub-object. For example, you can move vertices in vertex mode to change the shape of the object. By default, when you marquee select a group of vertices, the ones facing away from the camera are included in the selection. You can activate ignore backfacing to avoid that. You can scale, rotate, and move individual edges. The connecting geometry will adapt automatically. For the border mode to work, the object must have open ends, which this object doesn't have. I will switch to the polygon mode and delete one of the polygons to give the object a 4-edge border. The last sub-object mode is element mode. Elements are the parts of an object which are disconnected from the rest of the object. This object consists of a single element. I'll clone this element by shift-dragging. Now I have two elements. Deactivate the sub-object mode by clicking the button for the active sub-object mode or hitting 6 key. We have an object consisting of two separate parts. I'll go back inside and delete one of the parts. You can delete edges with Backspace without creating open faces. If you hit Alt-R, provided you're using the same shortcuts as me, or this button which says ring with one of the edges selected, the program will create a selection of a ring of edges going around the object. Here's another example. Similarly, with one of the edges selected, you can make a loop selecting by hitting Alt-L or loop button. You can modify the loop as a group. I'll hit Backspace while the whole loop is selected. The edges are gone, but the vertices at the intersection points are still in place. Now I'll do the same operation with Ctrl Backspace this time. This will remove not only the edges, but also the vertices on those edges. Most of the time, you want to avoid those stray vertices. I'll select an open edge and shift drag to create a new face. This also works with borders. Using this technique, With moving, scaling, and rotating, you can add geometry to your model. Shift dragging a face creates a copy of the face. I'll delete a face, switch to edge mode, and select two edges with a gap between them. Now, when I hit the bridge button, a polygon is created, bridging the selected edges. Here is another example. You can align parts of an object to an average plane, making them perfectly flat. I'll hit Make Planar button while this face is selected. Now the four corners are on the same plane. You can also use X, Y, Z buttons to align the plane with those axes. I'll add a Symmetry modifier to the object. Most objects you'll get to model will have symmetrical parts. This modifier places a virtual mirror which you can modify. Click the small plus sign and select the mirror and try moving it and rotating it. If you disable slicing along mirror, the result will be your object and a mirror copy of it. If you disable Weld seam, the object will be two elements perfectly symmetrical, aligned perfectly, but separate. The modifiers are not destructive until you collapse them. So you can go down on the list and edit the object, and the end result will be recalculated. This button shows the end result. My shortcut for it is N. Once you're happy with the end result and want to work on it at sub-object level, you can right-click on the name of the modifier in the list and click Collapse To or Collapse All. Collapse To will collapse up to that modifier. Collapse All will collapse all the modifiers in the list. While editing objects, you may end up in situations where the pivot point of the object is not anymore within the object. You can fix that by moving everything in the sub-object mode, or can use the center pivot point command. My shortcut for it is Shift P. You can access it in the Hierarchy tab by activating Effect Pivot Only button. That way, you can also move the pivot point to a custom location. Toggle the angle snap to make the object to snap to angles while rotating. You can set up the increments in the grid and snap settings window, which opens when you right-click on the snap toggle button. If you control-click on a different sub-object button while the selection is active, it will convert your selection. For example, if you select a face and control-click the edge button, the edges connected to that face will be selected. I'll select 3 vertices and convert the selection so that all the edges touching those vertices are selected. To close a hole on the object, you can use the cap button. I'll select this open border and click the cap button. The program will give you different editing options for each sub-object mode. You can see the buttons in the stack change as you move between vertex, edge, polygon modes. These 2 buttons are for growing and shrinking your selection. I'll select these polygons. When I hit the shrink button, the outermost polygons are removed from the selection. Grow button does the opposite. It adds all touching polygons to the selection. It works with the other sub-objects as well. You can magnetically align and weld these 2 open edges together. Activate Target Weld button. Click and drag to draw a line connecting an edge to the target edge. You can target the weld vertices as well. It's a good way of closing gaps. The weld button can also be used for the same purpose. It welds together everything within a selection as long as they are within a certain threshold. You can change the weld threshold in the weld settings. For precisely setting a number in these kind of boxes, you can type or you can reset the field to 0 by right-clicking and then using the small triangles. Let's say I want to split this object in half along the loop going through the middle. I'll start with an edge and make a loop selection. Then I'll go here and hit the split button. It will split that loop in two so that now I have two elements perfectly aligned by those loops, but not welded together. I can use the weld button to put the two parts back together. I will eyeball the two borders together, switch to vertex mode, select all the vertices along that line. Go to Weld option and tweak the threshold while minding the before and after numbers of the vertices. Hit OK button. Now all the vertices along the midline should be welded together correctly. You can check for errors by dragging polygons around. To connect two vertices on the object with a line, select them and hit the Connect button. My shortcut for Connect is Ctrl-Shift-E. Connect is possible for edges also. It creates an edge connecting the two selected edges by their midpoints by default. You can set up the number, position and alignment of the connection lines in the Settings dialog. I'll select one edge, make a ring selection and create two loops connecting the edges of that ring. Let's say I want these loops to be planar and parallel to z-axis. I can use the Z button next to the Make Planar button. Or I can select the loop and just scale it all the way down along the Z-axis. The second method is not as precise, but is good enough for most purposes. You can extrude faces out of your object by clicking and dragging up or down, while Extrude button is on. You can use the extrude settings for precision. Extrude mode matters when more than one polygon is selected. You can extrude them each separately or as a group. Normally, the program will calculate an average normal for the face being extruded and do the operation based on that normal. The local normal option here overrides that. You need it for when you want to extrude out polygons together facing different directions. If you extrude by polygon, each face in the selection will extrude separately. Bevel works more or less like extrude. First you decide the amount of the displacement, then the size of the tip of the extrusion by dragging up or down. I'll use extrude on an open border here. Inset is another tool I often use. I'll select this face and hit the inset button. With the button active, when I drag down on the surface, it's like bevel without the extrusion. It creates a new face connected to the original corners of the polygon. You can select the polygon, then shift-click an adjacent polygon to select a row of polygons along that direction. In this case, I'm selecting this ring around the object. I'll extrude that selection inwards based on the local normals, then inset the whole geometry. Then extrude some more to create this step structure as an example. To get rid of that complex geometry I've just made and go back to how it was before, I'll select one polygon, select a ring by shift-clicking, grow the selection, delete the selected part, and breach the gap. That newly created geometry after the last operation looks shaded differently. It's because Max assigned those faces different normals. It doesn't really matter how shadings look in the viewport for most purposes, but you can adjust smoothing groups or manually tweak normals to fix that. I'll just select those new faces and unassign any smoothing groups. Those 32 small buttons represent the smoothing groups. You can hit clear all to get rid of all the smoothing groups assigned to the selection. We had the same issue for the backside as well. I'll do the same for the backside. You can also select the whole thing and get rid of all the smoothing. You'll end up with one very crisp looking object. Swift Loop is another useful tool. You can find it in the ribbon under Modeling Edit. My shortcut for it is Shift S. It's for creating a loop of edges. Switch to Edge mode, hit the Swift Loop button. As you move the cursor over the model, you'll see a preview of the loop to be created. Click wherever you want the new loops. Right-click to deactivate Swift Loop. You can move vertices along edges by setting constraints. I'll select this edge, make a loop selection, convert the selection to vertices, and I'll click Edge in the Constraints list. Now when I move those verts, the movement will be constrained along the edges thereon. I'll make the four verts planar by scaling them along y-axis without breaking the flat faces in this case. With these four edges selected, I'll toggle the chamfer button and click and drag. It creates a chamfered edge. I'll go ahead and mess around with the chamfer tool. Let me try and fix this messed up geometry here using Connect and Target Weld tools. You can toggle Cut tool in any of the sub-object modes to draw lines on the surface of the model. It sticks to edges and vertices. You can right-click to end the operation. Push modifier is used for pushing sub-objects outward or inward the model along their average normals. It's for when scaling doesn't give the desired result. I'll select a loop, convert it to vertices, and while that selection is active, add a push modifier, then adjust the push value. I'll collapse the modifier once I'm done. It can be used with edges and polygons as well. Normal lines are hidden by default, but you can see them by adding an Edit Normals modifier. Each vertex has a normal line for each face it is connected to. Normals determine how faces interact with light. Smooth corners have normals with small angles in between or even unified. Here's a technique to start modeling an object based on a flat 2D shape. Switch to Top View. Select the Line tool in Create tab, Shapes section. Activate Snap tool to use the grid as a guide. Draw a closed shape by clicking for every corner going back to the point where you started. The dialog will let you close the shape. Then right-click and convert the shape to an editable poly, which turns your spline into a plane. You can change the color of your object if the outline is indistinguishable from the fill color. Selecting all the vertices of an object and hitting the Connect button will turn the object into all triangles. I'll model a quick object to demonstrate subdividing and smoothing. I'll add a Turbosmooth modifier. Turbosmooth rounds out the geometry in every direction and divides each quad into 4 quads for each iteration. 1 or 2 iterations is sufficient for most purposes. You can work on the object without removing the Turbosmooth and toggling the visibility of the end result. To maintain sharp edges with Turbosmooth applied, you need to create support loops next to the intended sharp corners. I'll add supporting lines with Swift Loop here. Chamfer or connect can be used for the same purpose. I'll chamfer this loop. Next, I'll do the same thing with connect. I'll offset the connecting loop closer to the existing corner. Yet, swift loop seems to be quickest way. As you can see, open ends are not affected by the smoothing. If you kept this border, the bottom of the object will round out towards the center. I'll add supporting geometry to end up with a flat surface at the bottom, using inset tool this time. For the other open border, I'll use shift scaling to add supporting geometry. To close the hole, I'll collapse the vertices to a single vertex at the center. Next tool I'll demonstrate is slice plane. I'll go to element mode, select the whole thing and toggle slice plane button. I'll place the slice plane along which the element will be cut into two pieces if split option is selected. Otherwise, it will work like cut tool. A continuous edge will be drawn, but the object still will be a single element. You can always split that loop with split button manually. You may want an object's pivot point copied to another object. I'll create a box here and convert it to editable poly. Then with the other object selected, I'll hit attach and click the box. Now the box will be a part of the object. Now if I select the box and detach it as an object, it will inherit its new pivot point from the object it has been detached from. can select an edge in the sub-object mode and make a spline copy of that edge. I'll select this loop and hit Create Shape from Selection button. It will create a spline of the same shape and location. Then I can convert it to an editable poly and edit it. Normal Align is another useful tool. Select Normal Align in the toolbar. Hover and click the face of the object that you want to move the set to normal to be used as reference. Watch the blue arrow. Then click on the surface on the object where you want your first object to align. Adjust the offset settings in the dialog and hit OK. The object will move and magnetically align. I will detach and isolate a part of the object for the next demonstration. Add an FFT 2x2x2 modifier. Hit the small plus icon to reveal the options. Select control points. Now you can move around the control points to deform the object. Collapse after done. FFT 3x3x3 and 4x4x4 serve exactly the same purpose. The difference is the number of control points they offer. Sometimes your objects need to be aligned at a point precisely. For that, turn snapping on and set snap settings to vertex mode. Move the object's pivot point to a vertex. Then drag the object by that new pivot to the desired location while snap is on. We can create instances of an object by selecting Instance in the Shift Drag dialog while copying an object. Changes done in one instance takes effect in all the instances at the same time. Mesh Smooth and Tessellate tools can be used at sub-object level instead of Turbosmooth in order to subdivide the object partially, although this is a destructive process. Here I will demonstrate how to use angle snap and instancing to build a radially repeating object. Make an 8-sided cylinder. Convert to editable poly. Detach one of the side faces. Its pivot point should be at the center of the cylinder. Turn on angle snap and shift rotate the object 45 degrees and create 7 more instances of the object. Now edit one of the objects to shape your octagonal column with repeating faces. I'll model a simple object, which I'll use in demonstrating texturing and UV mapping. I'll assign 3 textures to this object. I'll create a multi-material. Hit M key to open the material editor. Switch to the compact mode under Modes menu. We see 6 empty material slots in this view. The number of materials you can use in your file is not limited to the number of slots here. I'll use the first slot to create a material. Hit the button that says Standard, which is the current material type. Switch the material type to multi-sub-object. This type of material can group multiple materials together. Materials are basically a collection of image files called maps and some settings. We assign materials to surfaces to determine how they render. Our multi-material has 10 empty slots for submaterials. I'll assign a standard material as the first submaterial. Now I'm in that standard material. Hit this button to go back up to the parent material. I'll create 3 more submaterials. Let's edit material 1. Without any maps assigned, the material already had the default appearance. But we'll assign a diffuse map. Expand the Maps section down below. Find the diffuse color map and hit the button that says None. I'll set the map type as bitmap and find the files I downloaded from cgtextures.com for this tutorial. I'll pick one of the textures. It's important to toggle Show Shaded Material in Viewport button on. I'll go to the top level, assign diffuse maps for the remaining submaterials. You can drag the material slot over the object or hit the Assign Material to Selection button. I'll give names to all of the submaterials and close the material window. As you can see, the materials are assigned to the polygons quite randomly. To assign the submaterials to their intended parts of the object, I'll go to the element mode, select the top part, find the polygon material IDs section, find the ID of the correct material and set the ID. The roof tile is assigned to the top part. I'll assign the metal to the mid and the wrapping to the bottom part of the object. To project the materials correctly on the surfaces, we need to fix the UVs. I'll add an unwrap UVW modifier. With the ignore backfacing inactive, I'll select this top part and grow the selection. I'll hit the quick planar map button. It creates a quick flat map for the selection, which is not always accurate but gives a good starting point. Hit the button that says Open UV Editor. The checkered area in the Edit UVWs window shows the extents of our texture. Our selection is shown in red. When I hit Quick Planar Map button, that selection has become a UV island. I'll select the roof tile texture as the background image instead of the checkered pattern. As you can see, the tile is not aligned right. I'll select one of the 4 equal sides of the pyramid. I'll hit the Quick Planar Map button again to set that section as a separate UV map. You can see the green border lines. In the UV editor, I'll toggle Select by Element. It enables me to pick and move UV islands defined by the green borders. I'll isolate the selected part. F2 toggles the red selection overlay in the viewport. I'll freeform scale up the piece in the UV edit window. The texture tiles seamlessly. The bottom part of the roof is inverted, needs tweaking. Can move individual vertices and edges to fine-tune the mapping. There's also loop selection, ring selection, and grow shrink options here. You can copy the mapping for similar parts on the object. I'll try and copy the mapping to the other sides of the pyramid. For that, I need to split this UV island to 4 parts. I'll select the edges and use the break button. I'll paste the mapping to this new triangle. It will align itself to the exact position if nothing goes wrong. I must do one more splitting. The mapping for the fourth side doesn't seem to be calculated right. I'll quick planar map it separately, use the relax tool and align it manually. I'll select the mid part by material ID. Quick planar map doesn't really work for this part. I'll use cylindrical projection. There seems to be some unnecessary seams. I'll use target weld to fix that. I'll align the verts. For the bottom part, I'll use the peel tools. You can designate some seams and have the program spread out the geometry based on those seams. It's like peeling an orange. Peeling seams are blue. I'll create a seam going vertically at the corner and a radial seam separating metal midsection from the bottom part. Then I'll select the bottom part and use the quick peel. I should get rid of the unwanted green seams by making a quick planar map first. Then I'll peel and use the relax tool. Then I'll scale and tweak borders manually. Lastly, I'll model a simple butterfly. Start with a plane. Convert it to editable poly. Assign the butterfly image as a texture. Isolate the plane by hiding unselected. I'll divide the plane into 4 parts with cut tool. That is to prevent unwanted polygons to form while using the cut tool. Outline the butterfly image. Delete the polygons outside the butterfly shape. Using FFT, bend the butterfly at the middle. Unhide the other model. Scale the butterfly. Align the butterfly to the corner of the roof using snap and moving the pivot point. And that concludes this tutorial. I may follow up with an addendum or some modeling examples. I apologize for anything that may have bothered you, like my voice or my pronunciation. Thanks for watching.